Hi, physics. Mr. Janowski here. This is Chapter 13, Homework 1, Problem 8. This one's a little trickier than the other ones are. So, what's going on here? So, what is the closest that Mars and Earth get to each other? So, let's start with that. A sketch will help. Yes, it certainly will. This is physics. Sketches always help. So, let's call this part A. What is the closest that Mars and Earth get to each other? So, we're looking for a distance from between Mars and Earth. So this is equal to question mark something in meters. So a sketch will help. So how will this help? Well, here's what the solar system looks like. You've got the sun here going like that. You've got, Mercury. So this is not the scale. Yeah, Mercury's going around like that. You've got Venus. Maybe Venus is here. Venus is going around like that. But we don't care about Mercury and Venus. We care about the Earth and Mars. So maybe the Earth is here, and the Earth goes around the sun. We call that heliocentrism. Yeah, we've known that for a while. So that's the Earth going around the sun. And you also have Mars. So Mars might be somewhere else in its orbit. So here's Mars. Mars also goes around the sun. Boop. So something like that. So there's Mars. Now, what is the closest that Mars and Earth get to each other? Well, it won't be when Earth is here and when Mars is here. It will be when they all line up. So perhaps when Mars is right like this. So we've got that. Let me erase the paths of their orbits because that's only going to get in the way. But yeah, when they all line up nice like that in the same line, that is when they'll be the closest. Okay, so what we need to figure out is this distance here. That is the distance Mars to Earth. All right, well, look at the table. We know that the radius of Earth's orbit, let me color code this a little bit. The radius of Earth's orbit is this. Okay, so from here to here is radius Earth orbit. That is equal to 1.50 times 10 to the 11th meters. All right, and we know that the radius of Mars's orbit is this number here. So from here to here, radius Mars orbit is 2.28 times 10 to the 11th meters. Mars is a little bit further away. So yeah, which one of those numbers is our answer? It's neither one of those numbers is the answer. Our answer is the difference between those two numbers. So yeah, the difference between this distance and this distance is our answer. This distance right in here. So distance, Mars to Earth, when they're at their closest, is going to be the radius of Mars's orbit minus the radius of Earth's orbit. So that's equal to 2.28 times 10 to the 11th meters minus 1.50 times 10 to the 11th meters. So ask your calculator for that. 2.28 EE11 minus 1.50 EE11. And your calculator is going to tell you 7.8, I mean 0 if we're keeping with the sig figs, EE, so times 10 to the 10th meters. So that's an acceptable way to write the answer. Now, the way I wrote the answer up here was very slightly different. But that number would be equivalent, to convince yourself of this, to 0.780 times 10 to the 11th meters. So why would you ever write it like that? Well, just because the first one was in times 10 to the 11th, the second one was in times 10 to the 11th. So maybe it makes more sense to write your answer that way. Either way is fine. Those both work. All right, so what would part B be? When this occurs, what is the gravitational attraction between them? Okay, so for part B, we would want force of gravity between Mars and Earth when they're at their closest. So this is equal to question mark newtons. It's a force. All right, we have a formula for this. The force of gravity between Mars and Earth is going to be big G times M1. Let's make that the mass of Mars, times M2, the mass of Earth, divided by the distance between Mars and Earth squared. So the denominator is going to be our answer for part A. So yeah, fill in the numbers. 6.67 times 10 to the minus 11th, that's big G, times the mass of Mars. Okay, the mass of Mars is this number, 6.42 times 10 to the 23rd kilograms, times the mass of the Earth, so that's this number, 5.97 times 10 to the 24th kilograms. All right, so that's our numerator. Our denominator is, let's use this version of it, 7.80 times 10 to the 10th meters. And remember, that gets squared. Very easy to leave off the squared. All right, so we've got to do that in the calculator. 6.67 EE minus 11 times 6.42 EE 23 times 5.97 EE 24. You can hit enter now. You don't have to. And then divide by 7.80 EE 10. And then remember to hit the x squared button because the thing in the denominator has to get squared. And when you do all that, you end up with 4.20 something, something, something. And then it says E16, and this would be in newtons. But really, you should write your answer this way. 4.20 times 10 to the 16th newtons. So that is the force between the force of gravity between Mars and the Earth when they're at their closest to each other. And then there's another part to this problem, because why not? How does this force compare with the gravitational force between the Earth and the Sun? All right, so there's two ways you could write this. One way would be force of gravity between Mars and Earth over the force of gravity between the Sun and the Earth. So you could look for that. That's fine. The other thing you could look for is the flip of this. And because of the way I wrote the answer, we're going to look for the flip of this. So we're going to instead force of gravity Sun and Earth over force of gravity Mars and Earth. Like we're going to like this version better than this version. Just because of the way I wrote the answer. Doesn't really matter. All right, so what do we do here? Part C. We want force of gravity between the Sun and the Earth divided by force of gravity between Mars and the Earth. All right, now in problem 7, we actually found that number, the force of gravity between the Sun and the Earth. So in the previous slide, that was this, 3.52 times 10 to the 22nd newtons. So that one. Divided by the force of gravity between Mars and Earth. Well, that was our answer to part B. 4.20 times 10 to the 16th newtons. All right, so ask your calculator. 3.52 EE 22 divided by 4.20 EE 16. And you end up with 838,095 point something something. So yeah, there's your answer. So what that means is force of gravity, Sun and Earth, over force of gravity, Mars and Earth, is equal to 838, I'll write it, 095. So that's one way to write the answer. The other thing you can do is multiply both sides by force of gravity between Mars and Earth. That would give you force of gravity, Sun and Earth, is equal to 838,095 times the force of gravity between Mars and Earth. So what does that mean? Well, the force of gravity between the Sun and the Earth, even when the Earth and Mars are at their closest, the force of gravity between the Sun and the Earth is a way bigger number, 838,000 times bigger. It's way bigger. So yeah, this was a harder problem. Again, a sketch will help. It's physics. Sketches always help. So Hopefully this video helped.